Well, hello there. So today we're going to talk about the mesh analysis method, the mesh current method. As you can see here in this slide, we've got a step-by-step procedure, so similar to node analysis, and mesh analysis is built on Kirchhoffs Voltage Law. So our node analysis, we started with Kirchhoffs current law. Here we're starting with Kirchhoffs Voltage Law, which says that the sum of voltages around a loop equals 0. So we define these mesh currents in loops and use that law. We use Ohm's law along with that, just like in node analysis. And then in the mesh current method, you'll see that voltage sources, because they're in a loop and they have a known voltage, no problem. Current sources we'll see either make our life easier because they define one of the mesh currents, or harder because we have to do a super mesh. So the first thing we have to decide is what is a mesh. So a mesh is a loop. You can go back to the earlier lectures that define all of these things, but a loop that encloses no other loop. So you have to have the right number of meshes or you can't get a set of equations that will solve the system if you have too many meshes or not enough meshes. And I think the easiest way is to count the windows in a circuit. So the open spaces here that don't have other loops inside of them, those are meshes. You can do tricks with other mesh definitions, but this is the simplest one. We generally define mesh currents going clockwise. There's a very big difference between a mesh current, I1 and I2 in red here, those are mesh currents, and the current in the branches. So up here we have labels like we would use for Kirchhoff's current law, IA, IB, and IC. And that's the current through each of these wires, where I1 and I2 are the mesh currents, and it's not exactly the same. If an element is just part of one mesh, so here R1 is only part of I1, V0 is only part of I1, that current is just the mesh current. So IA here must be the same as I1, because IA is only in this one mesh, the I1 mesh. Same thing, IC over here, it's going in the same direction as I2 from left to right, and it's in this branch that is only touching the I2 mesh, so IC is the same as I2. So that's pretty normal. Where it changes is here, this resistor R3 is touching both the I1 mesh and the I2 mesh. And so the current through R3, we draw a line like IB here, we'll draw an arrow going down. And then we have to add and subtract the mesh currents according to this arrow. So IB going down is going to be I1, because I1 is going down through here when we're going clockwise, minus I2, because I2 is going back the other way. So I1 minus I2 gives us IB. So whenever there's an element between two meshes, you have to sum or subtract the mesh currents in the right sign to give you your arrow direction. Okay, so the first step here, just like in the node analysis, is to identify everything that we're going to solve. So we need to identify all the meshes, give them a mesh current, and we'll go clockwise. So that's what we've done here with I1 in red in the mesh 1. Mesh 2 here has I2. These are the book steps in gray. I also recommend here to label the voltages across each resistor, including a plus and a minus. That just saves a step when we do Ohm's law, makes it less likely to make mistakes. You can do it in your head, but it really is better to write them down, especially to get the signs correct. So here we have R1 and V1 with a plus and a minus there, R2 and V2 with a plus and minus, R3 has V3 with a plus and a minus. You can pick the polarity according to the current, you can pick it arbitrarily. It'll work out as long as you write something down and are consistent when we use Ohm's law. So now that we have our meshes defined, our mesh currents, and our voltages across the resistors, we can keep going. So the next step is for every mesh, we use Kirchhoffs Voltage Law. So here I've broken it down into the individual steps. We do Kirchhoffs Voltage Law, then we do Ohm's Law to replace the voltages with the mesh currents. So the first mesh 1 here, will go around the loop, and if we hit the minus sign on the voltage, we subtract it. Hit the plus sign first, we add it. So we subtract V0 plus V1 plus V3, and we're done. So we set that equal to 0. So there's our Kirchhoffs voltage law loop. Then we use Ohm's law on just the resistors, and we look at the sign of the polarity and the direction of the current. And so V equals IR if I goes from plus to minus. So this is Ohm's law's sign convention, and so we'll use it here. So V1 equals I times R1 because I1 is going from plus to minus. So V1 equals I1 times R1. V3 here is a little complicated because it's between two meshes. So it's I1 is going from plus to minus, so that's the right direction. And I2 is going from minus to plus, so that's the wrong direction. So V3 is I1 minus I2 times R3. Or if you remember back on a previous slide when we did IB times R3 is V3, and IB is I1 minus I2. So you have a positive sign if the if the current goes from plus to minus, a minus sign here on I2 because I2 goes from minus to plus. So we combine Kirchhoffs voltage law and Ohm's law, and we get our first mesh equation down here. All right, let's do it again. Here is the second mesh, so the I2 mesh. And we'll start over here on the bottom and go up. So we're hitting a minus V3 and a plus V2, and that's everything. So negative V3 plus V2 equals 0. Then we do Ohm's law, and we had V3 from the last one. It's still the same, I1 minus I2 times R3. And then V2, I2 is coming from plus to minus, so V2 equals I2 times R2. Combine these together, and we get this second mesh equation. So just taking a look at what we've got here, here is our mesh 1 equation and our mesh 2 equations. With some practice, if you do this every day, you will probably combine these steps and just go right to here and just go right to here. And that's okay. I still like to write the voltages so that I can really check the signs. If you look at the way the equations are set up, though, we have I1 in the I1 mesh. All the I1 terms are positive. So it's plus I1 R1 plus I1 times R3. And all the other currents are negative, the ones that come because they come in the opposite direction. So a minus I2 term here. The voltage is negative because we came up around the loop. So you have to check the sign on the voltage here. And then in the I2 mesh, all the I2 terms are positive and the other currents are negative. So that's a pattern that you'll find. It's not 100% reliable because if you multiply this whole equation by -1, you could have a plus V0, a minus I1, positive I2 minus I1. It's the same equation. So it works out here, and you can generally write the equations. Our book has a section on writing by inspection, by just looking at it. But you have to be very careful to get the sign on the voltage sources correct. So I still like to start off, write Kirchhoffs voltage law. Those sign conventions are very easy. Plus, plus, minus. Then do Ohm's law. It has a sign convention that matches up pretty well. And then combine them. You won't make any mistakes that way. Okay, so we've got our two mesh equations for our two unknown mesh currents. so we can arrange them into the matrix form. So here all of the I1 terms are factored out, and the I2 terms are factored out, and we can solve this with MATLAB or your calculator or any number of simultaneous equation solvers. Okay, so just to sum up, our steps are to find all of the meshes with unknown currents, and then do Kirchhoffs Voltage Law and Ohm's Law for all of those unknown mesh currents, and then solve our system of equations. Voltage sources just go into Kirchhoffs Voltage Law, so no matter how the voltage source is arranged, it's no problem. Current sources, we haven't seen any yet, but the voltage across the current source is unknown, so it either makes our life easy or hard. Just like in the node analysis, voltage sources made our life easy or hard. Everything's kind of flipped for the mesh analysis method. So that's it for this video. The next video we'll do some examples. And then the next video we'll talk about the super mesh.